All right, ready to solve two-step equations? Remember, two-step means there's two operations, not that there's two steps in it, definitely not. So it's a little bit longer process. Be patient with it, you'll get fast with it, so it's not gonna be that big of a deal. So here's how I want you to show it on your paper, on your homework. I want that line down the center, better line than that, please. I want you to go ahead and add opposite right here. Now, I want you to pretend like the 3 is not there. If that 3 wasn't there, it would just be a one-step addition problem. So how would you undo that? You would go ahead and do additive inverse to both sides, right? By adding a 4 so that you can make 0. So put that line there, go back up. You would have x equals 21, but there's a 3 still. So now drop that 3 right there. But now ignore this. Isn't this just a one-step equation of solving multiplication? Undo it with division. So you're going to divide both sides by the coefficient. There you go. So really what it was is you put two one-steps to make a two-step. It's not hard. This becomes 1 and x is equal to 7. And then when you check it, you go back to the original, drop that down, and go 3 times x, which x happens to be 7, plus negative 4. You want to make sure it equals what you started with, which was 17. And it does. 3 times 7 is 21, and 21 plus negative 4 is 17. It checks. So really all you did was you put two one-steps together to make a two-step equation. Always, always, always undo your addition first. Do not undo your multiplication and division. Undo your division first. Okay, let's try it again. So just because this one looks differently doesn't matter. You need to get your brain to work both ways. So leave it like this. But if you remember, you learned a property in chapter 1 and 2 called the symmetric property. And the symmetric property said, if 3 plus 2 equals 5, then 5 equals 3 plus 2. See, you just rotated around the equal sign. You could do that if you want, but I really would rather you just train your brain to work both ways and don't get comfortable with only one way of doing something. It's good for you, okay? So here's how we're starting off. Remember what I said, you always, always, always undo addition first. So you pretend like this isn't here and it's just n plus 8. So go ahead and add a negative 8 to both sides so that you can make your 0 pair right here, additive inverses, and then see what you're left with. Negative 5 equals n divided by 5. How do you undo division? With multiplication. Multiply both sides by whatever's in the denominator because you want to be able to cancel it like this. So both sides. So why don't I write over 1 here? Well, because this isn't a fraction, so I don't need to. Go back. And I have negative 25 on this side. And because I canceled those two, I have n. So n is equal to negative 25. Substitute it back in. I want the whole thing to equal 3. So 25, negative 25 divided by 5 is negative 5. And negative 5 plus 8 equals 3. It checks. It's just a little longer, but again, once you get used to doing it, it really isn't hard. You can go very fast. Time yourself. Try to see if you can get faster at it. Okay, so go ahead and do those two. Go ahead and pause it if you want. For x plus 3 equals 19. I'm going to go ahead and get rid of the addition part of this first with the additive inverse to make 0. 4x equals 16. Now I have to go ahead and get rid of the coefficient. It's multiplication, undo it with division. X equals 4. There's your solution. And then you go ahead and check it. 4 times 4 is 16, plus 3 is 19. It checks. Here, make sure you plus negative. Add 8 to both sides. W over 6 equals 4. Get rid of division with multiplication. Cancel. W equals 24. Check it. 24 divided by 6 is 4, plus negative 8 is equal to negative 4. Check. It works. It's not hard. It's pretty easy. Okay, formula is just really an equation, and just learn how to solve it. So if I tell you that the Celsius is 59 degrees Fahrenheit, well, substitute and solve. That's all you're doing. Just remember, you can't divide with the denominator divisor having a decimal. So if you move it one place here, you got to move it one place here, or be smart and just multiply both sides by 10. And then it would be 270 is equal to 18C. And then you go ahead and divide both sides by 18. Why did I multiply it by 10? Well, because I only wanted to move that once. If I had to move it twice, I'd multiply it by 100. And whatever I do to one side, I have to do to the other. So if I multiply this side by 10, multiply this side by 10. So a good way to get rid of your decimals. Same process here. You're just going to solve this problem, add a negative 19, then divide both sides by 10 cents. This is a really important problem. This will show up on several of your assessments because most people see it as a one-step equation, and it's not. It's two-step. This is why I promote adding opposite, because you need to get rid of that negative 1. If it was a positive 1, you wouldn't need to get rid of it. So the first thing we're going to do is negative 5. Always get rid of the addition first. Makes 0. And you have negative 1x equals 2. Not done. This is where the mistake always happens, right here. People think they're done. No, you got to get rid of that coefficient. The only coefficient that can stay is 1. Negative 1 divided by negative 1 is 1. That's the coefficient that can stay. X actually becomes a negative 2. So now check it. You go back to the very original problem right here. 5 minus negative 2 equals 7. Well, if you remember your chapter 2 rules, add opposite, you'll see 7 equals 7, and it worked. So this one's really, 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 really important. So make sure that you understand it. Take good notes on it. Remind yourself. Okay, so try to do it again. Pause it and try to do it. First, I'm going to put plus negative 1. I'm going to add 4 to both sides to get rid of the addition with the additive inverse. 13 equals negative 1m. Get rid of that coefficient. And m equals negative 13. And then you go ahead and check it back into the original. So this one, you actually have to combine like terms. So you have to see, this isn't a multi-step. You just have to recognize that you have to combine like terms. So first I would do this, and then I would do that, okay? And then I want you to notice you have like terms. Well, you can always go back to using clues to see that. So first you can see, oh, okay, I can combine these two like terms and get negative 2b plus 8 equals 18. Oh, okay, so now it's just a two-step equation. Go ahead and add your negative 8, your additive inverse over there. You have negative 2b is equal to 10. Multiplication, undo with division. Divide both sides by negative 2. And b is equal to negative 5. And then go ahead and plug it back in, check it and make sure that's correct. So remember, that's your additive inverse and that's your multiplicative inverse. Oops, sorry, I didn't mean to show you all those. So try it again. Remember, this is plus negative 1. So your problem will be 9 equals 13 plus 4x. Add a negative 13 to both sides, then divide both sides by 4. You should end up with negative 1. That's it. Two-step equations.